Welcome to Study Loop.
Our question says that an Olympic long jumper is capable of jumping 8.0 meters. Assuming his horizontal speed is 9.1 meters per second as he leaves the ground, how long is he in the air and how high does he go? Assume that he lands standing upright, that is the same way he left the ground. Okay, so I wrote what we were given here, and that's the distance he travels, which I call x. As far as the horizontal distance is 8.0 meters, and the velocity in the x direction is 9.1 meters per second. So we're asked how long he's in the air, and you can figure that out using what's given here. And that's because the distance he travels in the x direction is going to be equal to the velocity he's traveling in the x direction times the total time he travels. And this time is going to be true regardless of whether or not you're considering his horizontal or his vertical component. So we can find the total time he's in the air by using this formula, solving for t, which is going to be equal to x over v of x. And we'll replace those with what we were given, which was 8.0 meters. So we'll do 8.0 divided by 9.1 meters per second. The meters cancel, and all you're left with is seconds. So this is going to be units of seconds. Oh, I wrote 9.8, not 9.1. Let's fix that. This is units of second. Okay. If you carry out this operation, you find this equals 0.88 seconds. Okay. And that's actually the first thing we were asked to find. Now it wants us to find his maximum height he reaches in this jump. Okay. So in order to do this, we can use this equation here. Y is equal to y naught, okay, plus velocity in the y direction, right? Vy naught, the initial velocity in the y direction, times the time, plus 1/2 the acceleration in the y direction times the square of the time, okay? Well, the time we're going to use here, because we're going to do a little trick. We're going to say that y naught, the starting height that we're going to be considering here, is our maximum height, which is what we're trying to solve for. So we're going to assume we're going to start the timer when he's at his peak in his jump. So we're going to say y0 is equal to y max. Okay. Well, also the time we're going to use here, we'll call this ty, just to distinguish it from the other time. We'll call this ty. We're going to say the time here, well, since we're only considering half of the jump, is half of the initial time that we found. So it'll be t over 2, which is 0.44, because we're not considering the entire arc, right? We're just considering the last part of the arc. Okay? And then we know the acceleration, a of y, is gravity, right? Well, it's in the negative direction. It's acting in the negative direction, so it's minus g, which is minus 9.8 meters per second squared, right? And we're also going to assume that he lands on the ground. So the final landing position, which is y, is equal to 0, okay? And since he jumps in the x direction, at this point, there's no velocity in the y direction, okay? So we have everything here we need to solve for y max, or y of 0. So let's just plug in what we have. This is 0 is equal to y of 0, but plus vy of 0 is 0, so this is going to be 0, plus 1/2 times a of y is minus acceleration of gravity, which is 9.8, and that's meters per second squared, times t of y, which we said was 0.44 seconds. So this will be times 0.44 seconds. And this is squared. That's an s. Make sure it doesn't look too much like a 5. Seconds squared. Okay. And if we go ahead now and solve for y of 0, we find that y of 0 is equal to 0.95 meters. So that's the maximum height. And box that in as our solution.